Okay, so um all right, so you guys can see my screen, right?
Yeah.
Yeah, thank you. Okay, so let's just call it DSA 2.
Please zoom in.
Hey. Wait, did I not put 2? Wait. Something crazy is going on. Okay, still creating. Why is everything slow today? Yeah. Sorry,
Hello, guy. Hapana.
this thing is behaving very slow. Just to create a file and it's doing this.
Start your PC.
I'm too lazy to do that right now. Anyway, I think it's back. So, but no .js. Wow, do I really have to restart this thing? Okay, so I hope this is large enough. So today is DSA Lesson 2. So problem solving approach, right? All right, so let's take a look at this picture. It's not here. Okay, screenshots. Wow, it's still black. These guys are amazing. I tried to take a screenshot from Udemy, and the screen is black. I didn't know they do that. That's amazing. Nice one. Udemy 1, Eddie 0. Okay, so, so let me just let me just show you the places
Show us live.
in the browser. This is annoying though. Yeah, I think it's here, somewhere here. Introduction to solving problems or problem solving.
There, welcome back.
Like the thing is really amazing because see, if you, this was what I tried to do first. I tried to, use snipping tool. Once you click new, the screen just goes black. So I thought I could, fool them with the other one, but they still caught up. Nice one. This is annoying. Okay, anyway, let's just look at the objectives here. Define what an algorithm is. Devise a plan to solve algorithms. Compare and contrast problem solving patterns like, these. So, an algorithm is just a process or set of steps to accomplish a certain task. I know it sounds a bit underwhelming, seeing how algorithm is used everywhere and every time. Twitter's algorithm for I don't know, or showing you stuff, and maybe TikTok's algorithm for your For You page. But yeah, that's just it. The process of set of steps to accomplish a certain task. So when solving problems, you just try to outline, your steps, what exactly you should follow to achieve a solution to this problem, and that's an algorithm. Okay, so why you need to know it? Well, almost everything that happens in programming involves, an algorithm, and it's the foundation for being a successful problem solver and developer. This should have been solver. I also it shows up in interviews a lot because, well, they want to know your thought process. Yeah. Sometimes they could just ask you questions they are sure you know just to see how you think. So in any case, yeah, okay, how do you improve? Well, devise a plan to solve. The main thing with improving is just keep trying to solve problems and master common problem solving patterns. These are helpful things that would help you. These problem solving patterns will help you at least keep up with getting or rather writing code with good big O notation. Because a lot of times when we see problems, there's what might be called a naive way to solve the problems. A straightforward approach, brute force approach, and then there's there are better approaches you could use by applying some of these patterns or applying mathematical principles. Like we saw what we did yesterday. Where was that? We tried to sum up all numbers from 1 to a certain number. Right? Somewhere up here. Sum up 1 and 2. So this was the straightforward, brute force approach. Just loop through and keep adding up until you get to where you're going. But with a mathematical formula, we got a very straightforward O of 1 big O notation on this. So things that can help you improve your code are improve your algorithm writing or algorithm creation is mastering some of the common patterns that we're going to talk about today. Like you see how using frequency counter helps over here, and seeing how you can apply mathematical principles into what you're doing, like this. Okay. Yeah, we're over here. So, moving on. This funny guy. Okay, so understand the problem. These are the main steps. Understand the problem, explore concrete examples, break it down, solve or simplify, look back and refactor. Let me try and write them here. So,
I have a question. Sorry,
yeah.
I don't know if it's just, but your video is even blank to us.
Are you serious?
Yeah.
Oh my god! Wow, this security is amazing, really. Like, oh my god.
I don't know. Is it just guys? I can you see screen?
No,
Can you see
someone else
any-
confirmed that they can't see anything. It's just a gray screen.
Oh yeah. Yes. Yes.
I love these guys. They are very, very. I don't know. I didn't know they were like this. I also tried to take screenshots of it, but I couldn't. If you take a screenshot, it will turn out blank. You can. Where is that picture? I showed a
Okay.
picture of it.
Yeah, yeah. You can't even use it too.
That's amazing. This is the picture that I took. The screenshot. Okay,
You can't
so
beat the system.
as in, don't worry. Let me write it out. Okay, so these are the steps. Understand the problem. Explore concrete examples. break it down. Well, I really want to know how they did this. This is something we should look into. This security is just, it's very nice. Okay, and then look back and refactor. Yeah, so these are the steps. Understand the problem. This one is a no-brainer. Without understanding the problem, you can't truly solve it, because you won't be exactly sure what exactly you are trying to solve. And that's why when you go to the hospital, you tell a doctor you have a problem. The first thing they try to do is to understand the problem, ask you questions. What are the symptoms? What have you been experiencing? Do you have history of this, or does this run in your family? This one, that one, does this place do you like that? Okay, here, go to this place and take some checkup tests and let's know. They try to investigate your body to understand the problem, and then they also do this. Okay, this is explore concrete examples. If you watch, I don't know, I like to watch some medical movies sometimes. You notice that they would refer to successful maybe surgery cases or treatment cases from around the world when they are saying, okay, this person has a problem, we want to try and solve it this way. Yeah, somebody over there was successful using this method, so perhaps we can look into that kind of thing. So exploring concrete examples is just, if you can find something similar to what you are doing or what you are trying to do, and see how the person did it, or how that algorithm or code was written, here you can take some wisdom from there and try to apply it yourself. The good doctor, nice one. So break it down. This one, there was a video I posted some time ago on I'm not good enough.js, where guys are just coming. Now, wow. Okay, yeah. I'm not good enough.js. Somebody's mic is on.
Evidence. Evidence. Can you mute it?
Okay. Yeah, so sometimes a problem that looks very big would look a lot smaller if you just break it down. Like, okay, start with this, do this. So now this is where that solve and simplify comes in. So as you've broken down the problem into little chunks, you start solving those little chunks, and then you put all the code back together, and you have a working algorithm. So sometimes, at the beginning, it's not very easy. What's this one now? Luatoin.
Yeah, I'm with you.
Right, your mic was disturbing, I think. Oh, Tosin. Sorry. Okay, so yeah, at the beginning you might not write, will I say, the best possible code you could write. So this is where look back and refactor comes into play. If you notice, code was also do that. When you are done, there's test and what was the second one? Test and attempt, right? So after you test, you attempt, you pass all the test cases. They wouldn't just straight up say, okay, submit, or I don't know what the word is. They will say, try and refactor your code. Your code is working, but see if you can refactor it to get the best. Because at the first time you are trying to solve a problem, your mind is not completely going to complete efficiency. It's mostly, let me get to the end first. So when you get to the end, you look back, you'll probably see a few places you can refactor. Maybe some 2 lines of code you could combine into one safely. It doesn't mean that shorter lines means more efficient code, but some things you might find in your code will be unnecessary, and you say, okay, I can do without this, or I can find a better way to do this, something like that. Okay, so as for breaking it down, let me find something that would help us, explore this, break it down very well, and a good example as well. So we might just give me a few minutes.
Are there any in our object already? It doesn't have to be full pseudocode. It doesn't have to be valid, syntax. I like to do just little comments as a guide. And now I'm going to type up the skeleton focused, but also it helps you highlight the problems you might still not be confident about. And then you can just dive in and start writing the code. So let me show you what it looks like if I were to break down this. The fact that we only care about alphanumeric is not in our object. Add it. Go fill in the blanks. And I highly recommend.
I'm not finding the thing I'm looking for.
Probably tripped me up the most an insight into how this part works. So one more time, let's return to I is less than string.length.
Okay, in any case, let's just, so if you have a problem, let's look at this problem. Write a function to add two numbers. Okay, it looks like a simple, straightforward problem. So trying to apply some of these steps, we could ask ourselves, first of all, let me see, what are the inputs to, this, we call it function? What will be the inputs to this function? Like, ask yourself, questions all about the inputs. How many inputs will be given into the function? They've already mentioned that 2. What data types? Or, how exactly would those inputs be? Sure, they said numbers, but then it could also be strings. I mean, 2 in a string kind of counts as number. I don't mean it's the number data type, but would your function accept strings? How large of numbers are you expecting into the function? Because simply something like 56 and maybe 45 is a lot different from something like this plus I think I remember there was a code wars question sometime that someone posted about adding big numbers together, very large numbers. So this and this, you can see the difference in complexity. So all this, something like this, asking yourself questions like this can help you understand, will I say, how best to go about solving the problem. Also, again, outputs to the function or outputs from the function. What would the output look like? Would it be an actual number in JavaScript, like number data type? Would it be a string? Maybe also, if there are decimals, let me say what was added in is 56 points like that, and this one is this. Are you adding them and leaving all the decimals exactly as they are? Are you stopping at a particular decimal place? Are you removing a decimal place entirely? Little questions like this can change your entire approach to the problem. Okay, so well, that's that. Um, so let's go look at some patterns, some problem solving patterns. Oh, lots of people are entering today. So these are the few we'll be looking at. Frequency counter. Wow. Frequency counter, we kind of touched this, or in fact pretty much did this yesterday, but we'll just look through it again, probably, at least for the sake of those that were not here. The next is multiple pointers. So it's important to note that while these patterns are helpful in some cases, they may not necessarily be helpful in all cases. They have their specialties, you know. And so understanding these patterns involves not just knowing how they work, but also knowing or understanding where they shine best at. I mean, a goalkeeper is best in the post. You carry a goalkeeper and keep him, I don't know, as a striker, you will not get the best out of him. He may still walk grudgingly, slowly, but that's not where he's best at. Okay, sliding window. And the last to be divide and conquer. Of course, there are much more than this, but these are the few that we're going to look at. So don't rest on just these. You can also go ahead and look out for more patterns that would help you. These names, they might not, how do I put it? They are mostly unofficial names. So a lot of people came together and decided, yeah, let's name this frequency counter, or let's name this sliding window, something like that. So now this one, you know, I said after this we're going to be looking at searching algorithms, right? But in searching algorithms, there's just linear search that we're going to look at, and then 2 is binary search. So this binary search is a type of divide and conquer. So we're going to look at binary search when we come here. So at that point, there wouldn't really be much need to come over here, because linear search is what we've already been doing. It's like the way find works in arrays. That's array method find. It's just regular loop through something and just keep checking, is this equal to what you're looking for, is this equal to what you're looking for. That's linear search. For binary search, again, we touched a little bit yesterday, but we'll look at it more today. It's under the divide and conquer method. Alright, so frequency counter is a kind of algorithm where you store information about the data you are working with, usually in an object, because objects have, you know, very easy insertion access. Yeah, those are the two things those are two properties of objects that make them very useful in this situation, like what we tried to do yesterday. We wanted a function that would check 2 arrays and, you know, check that the numbers, where are those numbers? That the numbers in the second array are squares of the numbers in the first array, and all the frequencies tally, as there are 2, or rather 3 2s in this first array, this, and this, there should be 3 of 2 square in the second array, that kind of thing. And so frequency counter helps here because each time we look over this and we just check this guy appears 1 time, okay, here he appears 2 times, you just check, take note of all the items and how many times they appear. That's, you can see frequency counter, so count the frequency, that kind of thing. So when we came over here, we just start removing from the frequency. I think I had a console log here. Okay, let me run it again. Okay, seems this thing is a VS Code update. This black line. I'll go and change it. How did they remove my blue line? Okay, so this is what we have in the counter. This is the counter and empty objects. And we look over the first array. First of all, we square each number. The reason why I'm squaring the numbers is we want to check that all these numbers here have squares in this other place, right? So if we are doing that whole frequency counter thing, if we store these numbers exactly as they are, by the time we're checking through this, we won't be looking, would have a mismatch of things. And we actually had that problem yesterday. I stored 1, 2, 3 like that, and when I came in here I was looking for 1, 2, 3, but I wasn't seeing 1, 2, 3. And I remember that they were supposed to be squares. So if I had continued storing them as 1, 2, 3, then when I come here I would have to start looking for the square roots, and I don't know, I'm just more comfortable with squaring than finding square roots. So I decided to square here so that I'll be looking for the exact numbers in here. Okay, anyhow, at the end of this, counter square bracket square. So this is like insertion or updating of property in an object. We just add 1 to the value, and if the value does not exist, we make it 0 and add 1 to it. So 1 appears 2 times. 4. This 4 now is like 2 because the number is squared. So 4 just represents 2. 4 3 times, 9, which is 3, appears 1 time. 16, which is 4, appears 1 time. So that's it. And in the second array, we just started removing 1. So by the time it loops over here, it will remove 1 from this value. Check 4, remove 1, remove 1, remove 1. And each time any number, like the value for any number, drops to less than 1, it means it's an imposter. It's not supposed to be there. And so you return false. And if you are done looping through the second array and you don't see any problem, then you return true. So let's look at another example with frequency counter. Let me see, what will this function be now? Anagram, right? So let's see, maybe write a function that takes 2 numbers and checks if they are anagrams of each other. You guys know what anagrams are, right?
Don't know.
You don't know?
It's
Okay.
it's the word that spells same from the back and from the front.
And not just from the back and from the front. It's like if you switch up the words, if you switch up the letters in a word, you can probably get another word. Like all the letters of the word. So maybe
Can unscramble it.
it's like scrambling a word to get another word where you're using all the letters. So okay, look, let's take this. Takes can be scrambled to get steak. You see all the S S E E K K A A T T T, right? All the
Even
letters,
it's
all the letters in here are the same letters in here. No differences. It's just that they are swapped around, that kind of thing. So these are anagrams. So write a function that will take, oh sorry, not two numbers, two words or strings. Take two strings and check if they are anagrams of each other. Okay, so far we are trying to understand the problem, right? We want to understand what anagrams are exactly. So I take it we've understood anagrams from this explanation. Okay.
Yeah.
So basically we take the first string and try and take note of all the letters in it, and then check the second string, does it contain all those letters with the same frequencies. So if we are talking of maybe checking concrete examples, we already looked at one. These two questions are very similar actually. This one that we solved yesterday and this anagram question, they are crazy similar. So breaking it down, how do you think we should solve this? What steps do you think we should take to solve this problem? I'm asking you guys.
it's right function now.
You can rearrange the words first, the two words first.
We
Rearrange.
split.
Okay, so let's start with one person. Who said rearrange?
Yeah, like we can sort them in an like split them and then sort them and then match each and every character. If all are same, then it is an anagram. If one also does not match, then it is not an anagram.
Okay, so split and sort, right?
Yeah, first we'll split the string, store it in an array, and then sort it,
Okay.
and then with loop we'll match each and every character.
All right. So you guys understand that method, right? The first thing is split the array. Split the string. Then sort. In as alphabetical order, sending alphabetical order. And then loop. Okay, so we understand this, right? This writing the steps to your solution like this is called pseudocode, and it's a very helpful thing to keep track of what you are supposed to do or what you plan to do. So this is helpful for this. Break the problem down to simple steps. As it is like this now, I'm sure everybody can do. You can just pick one part of this and do it. It doesn't look difficult like this, right? So break it down and then you solve and simplify from each step. So let's try this. So let's call the function anagram checker. And it's taking string 1
And string 2.
and string 2. Okay, so So let's use these two, takes and stick. Alright, I think poker is activated, okay. But then we should be getting 0. Or rather undefined. Okay, so let's start. Split. The first step was. Okay, I should show. Split
Split the first one, split the second one.
Split the strings. Okay. So, who is helping us with the splitting?
Let's have you string 1
Let's string 1.
or let's sort splitted string 1
Okay. Sorry.
together as a variable
Okay.
equal to string 1 dot split.
Okay. So I believe we can do the same thing for string 2. Okay, so the string has been split. What next? We're sorting the array in ascending alphabetical order. To save time, we'll just use JavaScript. So I don't think for this thing, for words, strings, I don't know if there are other faster ones, but let's just
Don't you
use
just
the regular sort.
out?
Eh?
Like, we need to pass a and b parameter in the sort function.
Sorry, can you say that again?
Yeah, then it will work.
I don't know. I didn't hear you well.
Like to sort the string, the character array, while using that sort function, we need to just pass that a and b parameter and return like b minus a.
Okay, but since there are strings, b minus a wouldn't really work now. It would be like maybe a local compare b or something.
Yeah.
So, should we sort right here?
Yeah.
Okay, so. But then, sorry. Normally, sorts for strings works accurately. I don't know if you understand. It's for
Yeah.
it's for numbers.
Yeah.
It's for numbers.
Ordinary dot sorts.
Just ordinary dot sort is okay. We can console log this and be sure. Yeah, it sorts it as it's supposed to, in alphabetical order. Okay, so I can take this off. Alright, so we've splitted and we've yes, we've splitted and we've sorted. So the next step is just to loop through any of the arrays while checking that they have the same character. Both arrays have the same character at the same index. So before we get to that, I think we're missing something. We're missing an edge case. Edge cases are like in recursion, how we have base case. Something that would, a special condition that would make the function take a different direction from how it is supposed to go. So in this case, I believe an edge case would be checking the length of both strings. If both strings don't have the same length, it's pointless to go through the rest of this. It's false already. Yeah. Right? So if both strings do or don't have the same length, return false. Okay. Yeah, that's true. Alright, so I think we didn't even talk about the outputs. We talked about the input, but we didn't talk about what the output of this function would be. It should return true or false. If both of them are anagrams, it returns true. If not, it returns false. Okay, so adding our edge case is supposed to be at the beginning. So how do we write it? If both
If
strings
string
don't
one
have this,
is not equals to string 2 dot length, then return false.
okay. So if string 1 dot length is not equal to string 2 dot length, return false. If they are, then you can go ahead and do all this. So again, we splitted and sorted. The next step is the for loop. So how exactly do you want the loop to be? Hello? Guys,
For let's take
let what? String 1.
For let I equals to 0.
Let I equals to 0.
I is less than.
I is less than,
That's string 1 dot length.
yeah, string 1 dot length. Okay. So either way, whether we use string 1 or string 2, they are both the same length, so no wahala there.
Are we using string 1 or splitted string 1? We are using the splitted one. I don't know what you're using.
It's all the same, Sha. I mean, if you look at it, the string length and the array length are the same thing, so
Okay.
okay, so what goes in?
Then
What goes in? Is somebody talking? I'm not hearing.
Sorry, my network went off. I don't know. What's the loop for?
This is our pseudocode. If both strings don't have the same length, return false.
What's the loop for?
This is what the loop is for. This is what the loop is for. Loop through one array while checking that both arrays have the same characters at the same index. So if both strings, they are split and sorted, right? So you should be checking. This array index 0 should be equal to this array index 0. This array index 1 should be equal to this array index 1.
Can't we just check it?
Sorry, I'm thinking of something.
Can't we just do it?
Just join them together and see.
Yeah, like, I mean,
Yeah.
if we check, if splitted 1 equals to splitted 2, I mean, I thought something like that would work.
Instead of running a for loop.
If splitted 1, okay, join and check.
What you well, I think we are just following the arrangement here and go to refactor.
Okay, the pseudocode, okay.
So again,
The police are actually very nice.
yeah, it
I think
saves
it's
the
going to
loop.
actually like the police.
It saves the loop. Yeah, it's true. But anyhow, we've already created the loop. When we are doing the refactor, we'll look at that. So if we are doing the looping, how are we checking that at the same index both arrays have the same character?
I think we run another loop inside that loop.
Another loop? No, now it's not necessary now.
Bro,
You guys want me to write this thing?
You can say
Okay.
if secret string 1 into bracket I
Bracket I. Yeah.
equals to secret string 2 into I.
Yeah.
Then you can do anything you want inside the statement.
And what do we want to do now?
I don't know. It's not in the pseudocode.
Okay, it's not okay. Okay, that's true. I should add
Okay.
that. So if um
You return true now. What else do you want to
if
do?
how do I put it? If
What
both
do you want to?
if both characters are the same index, are not the same, we return false. Then if the loop runs successfully, at the end of the loop, I'm getting hungry for chicken all of a sudden. At the end of the loop, return true. So how about this? Is it clearer now? Loop through both arrays and check if both characters are the same index and not the same, return false. At the end of the loop, return true. So, can you guys mute yourselves? If you're not talking, mute.
Stop making noise. Okay.
Who's there? Where is foul now? That
So back to this. Everything is written out here. So what next? Is this the correct comparison? What should go inside here?
just return true.
Return true. Okay, let's see how that would work. Okay. So if I made this F, it's still true. You know why? Do you know why even though I made this F, this thing is still showing true?
Because we need an maybe else return false.
You want else if you don't false. Yeah.
It immediately exits.
Exactly. It immediately exits.
If it finds a correct option.
Yes.
Like
so
the correct condition.
Like a rule of thumb, putting return true in a loop, or rather in fact putting return in a loop should only happen if you want the whole function to stop if that condition is met. So the only thing that should make this function return is a falsy condition, like something went wrong, return false. But as for return true, we don't know if it's true until we get to the end of the loop. So you can't put a return true inside this loop. If you notice from the pseudocode, at the end of the loop, return true. But inside the loop, if both characters are the same index and not the same, we return false. So I will wipe these. So once again, is this the correct comparison? And what should be inside the what code should be inside the if statement?
I think it should be changed to if splitted string 1 not equal to.
Exactly. If it is not equal to, the character in string 2 at the same index, then what should happen?
It should return false.
Return false. And after the loop, what do we do? After the loop, what do we do? See, it's written here now.
Yes, after the for loop, it should return true.
Yeah, after the for loop, return true. So now, if we have an F here, it says wrong. But once we put the E, we get true. Okay, so what do you think the big O of this function as it is? By the way, I don't think we mentioned this yesterday. You know, we said a lot of array methods are O of n, right? Like map, filter, reduce. But sort, however, is
Yeah.
so
O of n squared.
what's wrong with this thing now? Yeah, O of n squared. Okay. So there are some kind of better, sorting algorithms, but even then, they don't really get that good. Sorting is not an easy thing. So this is about the best you can get for sorting. O of n log n, I think. So something that has to do with sorts, if possible, should be avoided. But in any case, at least we can avoid this loop over here by going with that join method, right? So some people came up with this. You join and join both. Okay. So this loop can go away, and then what do you return in this case? Where are the joined people now? Pauline and friends.
Me.
Okay, so if we were to split sort and join, what would we return?
We could just return splitted string 1 triple equal to splitted string 2.
Okay, yeah, so this gets us a true or false. But at the end of the day, this sort here has destroyed or very, very much raised. Hanging. It's hanging. Wow. MTN has been kind of bad today. Okay. So in any way, this doesn't follow the frequency counter methods that we're trying to look at, and this method itself, this sort, makes the big O notation, a lot higher than we want. So let's try anagram checker 2. Somebody needs to mute themselves. Oluwatoyin. Okay.
Yeah.
Your mic was not off.
We go beat you. Why did you disturb class?
Yeah, you want this guy.
Okay, so function anagram checker 2. Again, string 1, string 2. So I think let's have some kind of pseudocode for this. For this anagram checker 2. So once again, I'll just borrow this line. If both strings don't have the same length, return false. Right? And then after that, create an empty object. So store of string 1. Okay, then loop through string 1 and store the characters as keys and increase frequencies and record their frequencies. Okay, and then what next? We can loop through string 2. and keep reducing the frequencies for every character you meet. Okay, and if the frequency of any character drops below 0, return false. If the frequency of any character drops below 0, return false. At the end of the loop, return true. I will just take this line again. Okay, so this is what we intend to do in here, using the frequency counter method. So now that everything has been broken down into little steps, I believe anybody here can do this. So again, I'll copy this in here. So moving on, the next step, create an empty object to store frequencies. What would you like to name the object?
Please.
Yes.
I want to keep in something. If you
Alright.
want to copy an entire line on VS Code, can you just place your cursor anywhere on the line and do Ctrl C instead of highlighting everything on that line? You
Right.
get? So that works.
Yeah,
Save
thank
you a
you.
lot of time.
Alright. So moving on, create an empty object to store frequencies. Let me see. This is the empty object. So look through string 1 and store the characters as keys and record their frequencies. So who can help us with this one? Remember, we saw an example of this yesterday, right? When we did this. This is basically what we are trying to do right now. It's about the same thing. So how do we go about it?
Should I?
Yes, we should.
Okay, let's use for loop.
Alright.
Let I equal to 0. I should be lesser than st1 dot string 1 dot length I plus plus.
Okay, so what goes in?
If object that should be like square brackets.
You said if objects, so I'm writing.
Yeah, square brackets string 1 at I.
Yeah.
If it does exist, then we say this very thing plus 1, like object string 1 at I.
So I can just say plus plus.
Yeah, plus plus, yeah.
Alright.
S equal to 1, object at string 1 equal to 1.
Ah shit.
Object at string I
Equal to 1. Alright. Okay, so that takes care of this line. Loop through string 1, store the characters as keys. Yeah, string 1, square bracket I is the character at every point in the string. So we're storing that. Let's console log. Let's console log obj so we understand what's going on. Anagram checker 2. Okay, so you see T1, A1, K1, E1, S1, right? If it were to be a word that has something more, who has an anagram with, repeated letters? Well, and at any point you remember such, please holler. Let's move on. So the next step is to look through string 2 and reduce the frequencies for every character you meet. So just like you look through string 1, we look through string 2, and if you see, if you have an S, you look for S in this object and reduce the value by 1. So this will now become 0. And then if the frequency of any character drops below 0, return false. So for example, let's say there's an S and this one is also an S. By the time this first S will come, this will reduce to 0. When it meets this one, it will reduce to 0 again. Also, in the same way, if we had maybe an F here, F does not exist in this place. So we'll just assume that F is 0 and then remove 1 from that 0 to become -1. And once again, once we meet -1, return false. I hope that's understood. So who can help us with the second loop? Hello, there are plenty of people here now. Not be 23 people I see just now. It's even more than 23, sir. Somebody should speak up, please. For loop is not a hard thing. Write a for loop to loop through string 2 and reduce the frequencies for every character you meet. Hello, people of JavaScript. Okay.
Can the question again, please? Like,
you want to see the question again? Is this what you want to see? Is this what you want to see?
Yes.
Okay, so can you help us now that you've seen it? No, yes again.
Okay.
Let me try.
We should create a for loop for it.
Okay.
Let's equals to 0. It's I less than string 2 dot length.
This is not something you'll be thinking about now. Alright. Yeah, so what enters the for loop?
If statements, if objects, square brackets, string 2, then the I, yes, object string 2, then we are decrementing it.
Okay.
We need to compare it with.
There isn't really any comparison actually.
Okay, alright.
Once you just, like, if string 2, this S now, you just check, or it's just checking if S exists in this object, like as a key. So if S exists, reduce 1 from the value.
I guess not.
Else.
Okay. Else.
Object string 2 of square brackets I
Yeah.
is equal to
Is equal to
1.
no. It won't be equal to 1.
it's not so that's
It's equal to 0.
No, it will not be equal to 0. 0. It's already assumed to be at 0 because it doesn't exist. So if something is 0 and you remove 1, what would you get?
Plus plus.
Plus plus.
See, did you guys hear me? I say if something is 0
Minus.
and you remove 1, minus 1. Okay, so what happens next? Loop through string 2, reduce the frequencies for every character you meet. If the frequency of any character drops below 0, return false. So
That is if the character is not in that object.
yeah, at the moment we're just recording their frequencies, and then here we're now like ticking off the frequencies. So if you tick off a frequency and that frequency becomes less than 0, which is minus 1, return false.
yes.
Because
Return false in the else statement.
Return false in the else statement. So if I'm returning false, is there still a point to do this one? If I'm returning false only
No.
here.
No, there is no point in doing it. You should just return the false.
Return false. So but what about here? What about this situation? SS. Yeah, let's say we come here. Yes, S exists in this object. Okay, we reduce the value to 0. We move again, we meet another S. S exists in this object. Yes, we remove 1, becomes minus 1. But then we still move on. There's no checking of anything here to make us, to check if a number drops below 0. You understand what I'm saying? You are only looking, this is your else now, and the return false only covers this situation where there is a strange alphabet that doesn't originally exist in this object, in this obj, our frequency counter here. At that point you immediately return false. But in a situation where a character that has existed before now has more frequency than it should, that is supposed to be happening in this if. How do you catch that in here? Essentially put another if statement. Hello?
We could use ternary now, like.
Okay, so how do you write that? Besides, anyhow, how do you want to write that, Sean?
What are you trying to write, Eddie?
Loop through string 2. We're looping through string 2 and reducing the frequencies of any character we meet. This is what's happening here. That's why I said, if that value, that character exists in this obj, reduce 1 from the value, right? But now there's a check. If the frequency of any character drops below 0, return false. So how do you check that here? Here you are just reducing the values. Okay, this character exists in the object, good, reduce the value. But now you have to check if the value is below 0 after you have reduced it, return false. It's not supposed to be difficult now. It's a regular if statement.
Okay, we could go below this object minus object string 2I.
Okay.
Then we say if object at string 2 is I is less than 0.
Take it again. Is less than 0. Okay.
Yeah.
Alright, so we return false. Okay. So what next? This was what we just did. If the frequency of any character drops below 0, return false. So this is the next step. At the end of the loop, return true. So after the loop has finished running, return true. So here we get false. If we have an F, we still get false. But if we put a T, we get true. So this looks like it's working. If you put an extra character, the first, you can see everything is white. This line is where everything stops. Return false straight up here, because there's an extra, the lengths are not the same anymore. Okay, so yes, this works, but I believe this thing in here and this in here can be, what's the word, refactored. Okay, so take a look at how it was done yesterday. The object here, we named it counter. Counter, you know, inserting an object into a property into an object, checking the value of a property in an object, updating the value of the property. Now they are done in a very similar way, like this. Counter square maybe is equal to something, or to check the value you just say counter and a property inside, that kind of thing. So here we're saying get this and assign it to this. So we check counter and a key inside first of all. If it exists, then you know how OR works. If this value is truthy, it will move on. It will return this value from this expression, from this comparison, or what? Yeah, it's expression. Return this, and then you add 1 to it and assign it back to here. If this is undefined, it's falsy, so it will move on to the next value. And since this is the end of the expression, it will return this. Okay, so we can use that here for this place. So comment this out and say obj str1 square bracket I is equal to or 0 plus 1. See, we get back the same thing. So this saves you a lot of line, and if you ask me, it's still readable. Okay. So can somebody, you know, do something similar for this? Something like this. Can you do it for this? Let me comment all this.
OBJ string 2.
Okay, so let's use the method we're talking.
But for the first one, please, can't you use like plus plus instead of that plus 1?
Can you use using plus plus will be here that you use it, or do you want to use it here? So, let me see.
I'm just wondering.
Yeah, it doesn't work.
Okay.
We could have straight up used it here. The problem with using it here is that there's this possibility that this property doesn't already exist in here. So this would return undefined. Undefined plus plus is not will not work. You can't increment undefined.
Oh.
So we have to do this.
Yeah.
So what changes do we make here? Okay, this is string 2. So obj
That should
string
be
2
-1.
minus 1. Fine. Yeah, so this takes care of things, If that character doesn't already exist in obj, we give it the value 0 and subtract 1 from it. Then we can now do this check. So if obj string 2I is less than 0, return false. And you see we still get the same thing. So if we try F, we get false. If we try another S, we get false. So this is a refactoring of the code. I think I can remove this now. It has served its purpose. Okay. So is this understood?
Could you please add something like Z in that second string?
Z. Where? At the end?
Like that, yeah. Yeah.
If it's at the end, then this is what would stop it from working. The length will no longer be the same.
Could you please make the length the same?
Okay, let's...
I'm just wondering if the string obj string 2I will always be less than 0.
String 2I would always be less than 0. Okay. If like
okay,
this sticks, then it will never be less than 0. They will just be removing themselves 1 1 and be turning to 0, but they will never get less than 0 because everything is in the exact frequency it should be. So it will return true. And these two lines will not run properly. Okay, so that's frequency counter. So let's move on to time has gone well. Sliding window, sliding multiple pointers. This one, Jenna.
Eddie, I would have loved to take a screenshot of the code. Maybe.
You will still see it. You can see it online later.
Okay.
I will push to. You can off it. I'll push to GitHub. So for multiple pointers, let's go look at something here. Okay, so 2 pointers. Some people call it 2 pointers. It's mostly 2 pointers they use, even though it's called multiple pointers. It's rare to see people use 3 pointers or 4 pointers. You mostly see 2 pointers. So it's alternatively called 2 pointers. 2 pointers is really an easy and effective technique, which is typically used for searching pairs in a sorted array. So the thing with this sliding window and multiple pointers algorithm or method is that they mostly work on sorted arrays. So for unsorted stuff, so a lot of times frequency counter or something else is usually better. Okay, so given a sorted array having n integers, finds if there exists any pair of elements such that their sum is equal to a certain number. Sorry. So you'll be given an array, I guess a sum of number, or rather the length of the array. I don't know why they're doing that. And then x. X is a number that's, you should find 2 elements of the array that it adds up to. Okay. So this is what they call the naive solution. It's a nested for loop. You loop through the array, and at each point you loop again. So you would have 2 things you are adding together. If the value at I is equal to the value at j, you continue. Okay. Well, let's copy this and and see how it works, and then we'll also look at the sliding sorry say sliding the multiple pointer method of solving it. This just tickles me wrong. Okay, so for why is it var? For let I is equal to 0, I is less than n minus 1, which n is just the length of this array actually. I less than n minus 1, I plus plus, and let j be I plus 1. So j starts, or j is always higher than I. J stops at less than n, j plus plus. So equal I and j means the same elements. So if I is equal to j, continue, and if you find a pair such that that element in A and the other element in A added up together equal x, return 1. A of okay, so if you ever meet a pair, since the array is sorted, if you ever meet a pair that when you add them together it's greater than x, there's no point looking further. It's like you have, where was that array we had yesterday? There was imagine this array. You are trying to find two numbers that when you add them maybe you get 9. If you add 4 or maybe let's say you are looking for two numbers you add, you get 7. If you add 3 and 5, you get 8, right? Okay. So there's no point checking 3 and 6 and 3 and 7, because 3 and 5 already gave you a number higher than 7 here. So you can just break there and move to the next loop in the original, the first loop, the next iteration of the first loop, right? Okay, so that's what this is for. Okay, this return 1. I guess that's return true, while this is return false, but they are returning 1 or 0. Okay. Okay. So we have an array, size of the array 1, 2, 3, 4, 5, 6, 7. I don't know why they still felt the need to give size of the array, but all the same. Console.log, what's it called? Is pair sum. So we have array, we have array size, which is n, and we have val. So we get a 1 because val is 17. We're looking for two numbers you add and you get 17, and yes, they exist, 8 and 9. If you add them you get 17. So, but I don't know, I'm more comfortable with true or false, so I'll just change all these to false and change the return 1 to true. Don't know what's wrong with these guys. Okay, so we get true. So let's look at, this was if you remember O big O notation, this is like O of n squared. You're running a loop through the entire array, and you're basically at each point in the array you're running a loop through. Okay, kind of. kind of n log n. Well, at each point in the loop, you are running another loop through, a portion of the array. So let's see if we can make it better with multiple pointers. So now let's see how the two-pointer technique works. We take 2 pointers, one representing the first element and the other representing the last element of the array. And then we add the values kept at both pointers. The pointers are like indexes that we use to access the array. So if their sum is smaller than x, we shift the left pointer to the right. If their sum is greater than x, we shift the right pointer to the left. Okay. So remember, 2 pointers. One is at the first element, the other is at the last element. So it's like you create maybe 2 variables, I and j. Let I be equal to 0. Let j be equal to array.length minus 1. So that means I is holding, or I is the index at the beginning of the array, j is the index at the end of the array. So you add those 2 values together. If the sum is smaller than x, you shift the left pointer up. So to explain it, using this array, it's like this is I. This is I, and this is j. So add them. 3 plus 11 is 14. It's okay. This is wait, this is supposed to work for a sorted array, right? Anyway, yeah, you add these together, 3 and 11. You have, it's smaller. But from what they described here, if the sum is smaller than x, we shift the left pointer to the right. If the sum is greater than x, we shift the right pointer to the left. Okay? So the sum is smaller than x. We're looking for 17, so we shift I to the right. And that's like this. This one comes back. Then you add again 5 plus 11, 16. It's still smaller. You shift this up to 9. 9 plus 11, 18. It's bigger. So you shift this one backward. 9 plus 10, 19. Shift it backward. 9 plus 8, 17. You return that. Return your true. So I guess if you were to come down and get to this point, where the difference between I and j is like just 1. If that one still doesn't satisfy what you're looking for, then you return false. Okay. So if this this explanation and this example doesn't do it for you, it helps with respect to understanding it, that's okay. Frankly, me and multiple pointer, we don't jam very well. That's why I'm explaining it from here, not from my head, like with frequency counter. Me and this thing, we don't jam. But all in good time, sure. One day it will be part of me too. Okay, I can remove this since they are the same thing. Wait, I copied the same thing.
The function name, right?
The feels like okay. Okay, is a different thing. It looks no. This is Okay, I didn't click copy. I didn't copy, I just pasted. Yeah, this is different now. Okay, so function is pair sum. Let's make it is pair sum 2. Are you still crying?
Is it I and J did that up there?
Ah.
Up, the I and J. When you were
Okay, sorry. So first pointer, beginning of the array, I is equal to 0. Second pointer, end of the array, n minus 1. Normally we would have used array.length minus 1, but they were gracious enough to give us the size of the array, so n minus 1. So while I is less than j, okay, so remember what we were doing before. The 2 pointers are slowly moving towards themselves. Okay, so while I is less than j, so if at any point j comes here or I comes here, that's it. You don't end with that. Okay, so while I is less than j, if we find a pair where a is the number at that index plus the number at the second index added together gives us what we're looking for, x, you return true. But other than that, if the sum of elements at the current pointers is less, we move to higher values by increasing I. Remember, we're pushing I up anytime we meet a value that is less, like 3 plus 11, just smaller, so we moved I upward. Okay, so I plus plus.
How is the addition happening? Is it from the beginning, like 3 plus 8, and then we move on like that?
Okay, remember we started the pointer here and here, right? You remember that?
That's 3 and 11.
Yeah, 3 and 11. So you add the elements at those positions, like array index I plus array index j. If it is smaller than what you're looking for, x is 17, which is the value you're looking for, 17.
Oh, x is 17.
So if it's smaller than 17, you move I up. If it's bigger than 17,
that is move I to front.
Yeah, I plus plus, make I shift up by 1.
So I will be at 5 and j will still remain at 11.
Yes, j will still remain at 11. So 5 plus 11, 16, is still smaller than 17, so we move I upward again. I comes to 9.
Okay.
Then 9 plus 11 is bigger than what we want. 9 plus 11 is 20. Yeah, so it's bigger. Yes. So we move j downwards.
J will be at 10.
J will be at 10.
I will still be at 9.
I will still be at 9. So 9 plus 10, 19. Still bigger. Move 19. It down again.
Okay, yeah. So 9, 8.
9, 8. And 9 plus 8 is actually 17. So so this if statement would catch it. If a array index I plus array index j is equal to x, return true. So but otherwise these ones will be happening if the sum is less than the value we're looking for. Increase I, move it up. Else if it's not smaller, then it's bigger, because we've already eliminated the equal to, right? If you are comparing two numbers, they can only either be equal to each other, if you are comparing, they can only either be equal to, less than, or greater than, right? So we've compared, or we've said what should happen if it's equal to, said what should happen if it is less than. So the only other situation left, condition or possibility left, is that it's greater than. So that's why they said else instead of another else if. Else if would have still been correct there. It's just, you can save yourself a few characters by just writing else. Else, j minus minus. So this is understood, right? This from what we explained, right? So
Yeah. So that means each J and I, they are indexes of the array.
yes, yeah, they are created as to be indexes of the array. Indexes we used to be looking at the array. So anyway, you would always have this. This will be uploaded to GitHub, so or pushed to GitHub, so you can always come here and look at it. So let's move on quickly to sliding window. Is it this? Okay. So this one, I'll just let me see. What's even the question? So, given an array of integers of size n. Okay, I think I should copy this question into the applet so that when you see it, you would understand what you were trying to solve for. So given a sorted array, find if there are any pair of elements such that their sum is equal to x. Yeah, they said a sorted array, but they gave us an unsorted array because this is not sorted now. I don't know why they did that. Anyway, coming down here. So let's have the question again. Yes, given an array of integers of size n, calculate the maximum sum of k consecutive elements in the array. That means if you have 100, 200, 300, 400, and they say k is 2, that means find the largest sum of two consecutive numbers. As in 100 plus 200 are two consecutive numbers, keep their sum one side. 200 plus 300, two consecutive numbers, keep their sum one side. 300 plus 400, two consecutive numbers, keep their sum one side. Which of the sums is the largest? You understand? That's what this question is asking. Okay, so as you can imagine, the in quotes naive solution would be to run a loop over the array, and for each element you just run a small loop of k, or rather maybe up to k. Let this be k, and try and run a small loop to get the next character you want. Add that together, keep the sum one side maybe or something. Go to the next one. This one is because k is 2 that is looking kind of small. Let's look at this one that k is 4. So from here you would run a small loop to get the next 3 numbers and add them each time to get a sum. You come to this place, you run a small loop to get up to 23, add them up. Come here, another small loop to get up to here, add like that. So that would be the naive solution, but since we don't have time, we'll just skip that, move straight to the sliding window solution. So their own solution now is, let's use this one. It's a better array, right? So at the beginning, you add up the first 4 numbers, okay, and keep that sum somewhere. Also creates how do I put it? Creates a variable that would hold the maximum sum at any time. And so you can start that as 0 or something. So run a loop through this array, starting from I plus 1. Sorry, starting from 1. Yeah, because this was already 0. The first sum that you just did here was already 0. So you can start from 1, and you are stopping at here, the length of the array, like minus k, that kind of thing. You are stopping here. So at first you added these numbers, right? So when you come to this place, what you do is you delete this one and add this one and have that to be your new sum. So you compare it with max number. If it is greater than max number changes. If it is not, well, everything remains the same. And you move to the next one. It's like a window. That's why it's called sliding window. Okay, so now when you come here, you delete 4, add 3. Check again, is it greater than max number? Do whatever you're supposed to do. Slide over again here. At this place, you delete 2, add 1. So at each point, you just have the sum of those consecutive numbers. So you don't even really have to loop through the entire array. You just loop from like here to here. That's all you're doing. You're looping n minus k times. So at the end, you would have a max number. So let's quickly look through what they did. They're still collecting n. These guys are interesting. Array 2. So console.log, what was this called? Max sum. Array 2, this is taking n and k. N and k. So they had the guts to use capital K here. Wow. Okay. So we're supposed to return the largest sum. But let me see what is, but this is not the largest sum actually. This code is supposed to work on a sorted array. So they should have actually given a sorted array. But anyhow, let me just so if we were to sort this, actually we would get 0, 1, 1, 2, 2, 3. Three, 4, 10, 20. Oh. Yeah. Something is not right. I don't understand. What's missing here? Why is that when I sort it I get 34? But without sorting it's 11. It's just strange and weird. Anywho, let's look through this first. So we initialize a maxsum variable. Let maxsum be 0. We run a loop from I to k. K is 4. Okay. Right. So new person. So this was what I explained here. Where was that place? Yeah, that at the beginning you just get, the first sum, the sum of the first k, items. Have that first of all before you now do the actual loop, the main loop. So this was what they did to get, the first value of maxsum. So initialize a window sum and assign that maxsum for the window sum. Okay. So the window is like this, the sliding window. At the first time it's like this. The next time it slides over and becomes like this. So you remove 1 and add 23 to get the next window. The next time you remove 4 and add 3. Right? So when they say window, this is what they mean. It's like you're sliding it upwards, removing the one at the beginning and adding a new one in front each time. So that's the window sum they are talking of. So let window sum be equal to maxsum. So for I equals to k and I less than n. Okay.
What is n?
N is the sum of the array. Sorry, not sum. N is the length of the array.
Okay.
So that means I is starting at, for example, here now. This was the first thing. I is starting here. Right? And it's ending here. Okay. So when I gets here, you pop off, let me see.
That is starting from the back.
Not really the back. Let me copy this array in here so that we'll just look at it. So this is the first window we had. Window sum is equal to max sum here. So for I is starting here, I is starting at k. K is 4, right? So the 0, 1, 2, 3, 4. K is starting here. So the new window sum now would be the previous window sum minus array square bracket I minus k. I is 4, k is 4, because this is the first iteration of the array. 4 minus 4 is 0. So from the current window sum you remove 1 and then you add array square bracket I. You add 23. The previous window sum was like this. You remove 1 from it and you add 23 to get a new sum. Okay. Then
okay, you are removing the okay, then
remove this, add this. So your new window sum is like this. The next time you remove 4, you add 3. So this will be your new window sum. The next time you remove 2, add 1. New window sum, like that. So each time you just check math.max, max sum and window sum. So the current max sum and your current window sum, which one is bigger, becomes the new max sum. So at the end of the loop, return max sum. Yeah, so that's just how it goes. Let me try something else. This is just interesting to me. Console.log array2. Oh, okay, because I didn't source it with this. I see, my bad. Let's now understand what's going on. Well, let's have this the way it was. Okay, that's why it was taking this as its window. This was the largest window, 10 to 20. Okay. But it's actually supposed to return this 3, 4, 10, 20. But it's stopping at 11, and that's just is shocking to me. 3, 4, 10, 20. Why is it even getting 11? I need to have some window, let me console log window sum and mark sum each time. Six, 8, 11. Array 2, N and K. Do we have another N and K somewhere? We don't. Okay, array 2 dot length. Let me cause this one. Exactly, 37. This is what it should be, 37. So the problem was this. I was using array dot length, and this is, where is array? This is array. It's a different, different size. So it was not getting to the end of the array. It was stopping maybe here. Oh, give 13. This is 7 plus 11. Yes, it was stopping here. It wasn't getting to these two last values. That's why we're getting 11. Okay, so finally divide and conquer. Let's see how fast this can be. So that will close. Actually, quite a bit of sorting algorithms use divide and conquer. You see, they came up, some crazy people came up, I don't like, not like they are crazy sharp, but I mean, who thinks that way? So they are crazy. They came up with this idea that, or will I say finding, it's not just an idea, that an array with 1 or 0 item is already sorted. So they break they break down arrays. That's the whole divide. That's why it's used, to show an example of divide and conquer. They'll break down the array until it's, empty array or one item in it, and then start merging it back. So if you are merging 28 and 37, you sort them. Which one is smaller comes in front. At this point now, you now do some kind of sorting. The smallest item, the first item and the first item here, which one is smaller? That one goes in first. So this one and this one, which one is smaller? This one, it goes in first. This one, this array has already, 38 and 43, which one is smaller? 38 goes in, 43 goes in. It looks crazy, but at the end of the day, you find out that this is faster than, starting from here and looking through which one is smaller than this, that kind of thing. At the end of the day, it's faster. But I think the one we're going to use to show this divide and conquer is just...
I'm looking at that.
You had what?
I think looking at that.
That's wonderful. That gives me joy to hear. Okay, so I looked around for examples of this, and I just kept seeing, what's it called? I kept seeing sorting stuff, and I don't want to do that yet. So let's try and complete this our binary search from yesterday. So by the time we're done with that, we'll end the lesson, because like I said, linear search doesn't have much in it, and binary search is, well, what we're going to use to show an example of divide and conquer. So once again, binary search, the thoughts behind binary search is you are searching for things in a sorted array. A lot of these things work with sorted arrays or sorted data. Yeah, you're searching through a sorted array for a particular number. let me say you're looking for 10. So you just take a random point. Personally, I would like to go with midpoints. You find the midpoints of the array, with the size, with the length of the array. So if this is 10 things, you just take 5. It doesn't matter whether it's the actual midpoint. Point is just take somewhere. Okay, so let's say this is 5. This value, this will be 5, I think. This value, is it smaller than what you're looking for, or is it bigger? If it is smaller, then it means you should go this way, like to the left, to look for your value, right? It means, if this one is already, what did I even say? If 3 is bigger than what you're looking for, it means the rest of the things on this way are even more bigger, or even bigger than what you're looking for. So there's no point checking these ones. You just throw this whole array away and pick these ones. Okay. And pick on that point. Let me say you pick here. This one, is it smaller than what you're looking for or bigger? Let's say it's smaller. It means the things to the left of it will be also smaller. So you throw those away and look at the remaining ones. You pick a random value. Smaller or bigger, it's the same. I found you. Right? So that took like 3 steps. With a linear search, you would have had to go 1, 2, 3, 4. Okay. Well, you would have stopped here, but in general, a linear search has the potential to go as many times as n. That's the worst case scenario. But binary search cuts down that time drastically. You see, no matter if we're looking for 10 or 0 or 20, we would hardly, for an array of this size, we'll hardly loop more than 4 times, I think. Let's try it. We're looking for 10. Let's say you pick the middle point as 3. 3 is smaller than 10, right? That's one loop. So you abandon this and you move up to this. Imagine you take the midpoint. Okay. Imagine you take the midpoint of this. You're already at 10. But even if you took it at 4, this is the remaining array. Even if you say it's 4 you want to look at, smaller or bigger? Smaller. Throw it away and look at these two. Even if you took this one and throw this one away, come back down here. That's 4 iterations. So that's the thoughts behind this. Okay, so this is half index. Let's console log that. Wait, what's that sound? Yeah. Is it the clipper?
I can't hear anything again, no. Is it just me?
Can you guys hear me?
The screen.
Yeah. I hear you now.
I hear you.
And then it's not helping me out. Okay, I think it's showing now. This is just what I wrote, half index. Okay, so once again, we check the 3 possibilities. Is our number greater than half index? Is the number at half index equal to our number? Is it less than our number? Is it greater than our number? Those 3 things. Something should happen, Okay, so let me see. Okay, first of all, if it is equal to let me see. If it's equal to n, we'll return half index, right? Return half index. This will be put in a loop later, but let's just write that out. So or rather else if what's wrong with me? else if array square bracket half index is less than n, what do we do? And then else, if it's greater, what do we do? So if it's less than n, that means all the things to the left of that half index can be ignored, right? So we should only be looking at things on the other side. So we have to create a new half index. So the new half index, let's see. Or instead we change the array. So
if it's less, sorry,
yeah.
if it is less, it means that the result will be there, right?
How do I put it? Like this. Let's say we're looking for 3 in this array, and your half index is here. You select 2. 2 is less than 3.
2, okay.
That means you are throwing away all
Yeah.
of this. So let me see. 0, 1, 2, 3, 4. Right? 4. If we say console log array 2 dot splice 4. Okay, should be 4 plus 1. No? 0, 1, 2, 3, 4. What 2 did I pick? Let me say 5. Let's assume it's 5 I picked. It starts with 3. Okay, so 5 plus 1. Okay. So array dot splice. Sorry, not 4. Half index plus 1. And if it is greater, that means array should be equal to array dot splice how should it splice now? Let's say I picked 3 and 3 is greater and I want to abandon all of this. How would I splice? Or should I just use slice? Slice is easier to work with. Slice is easier to work with. Yeah. So if I were to slice, let me see, this is 0, 1, 2, 3, 4, 5, 6, 7, 8. 5. This is 5. So if I want to throw away all of this, then what would I say? 0 to 5, right? 0, exactly. 0 to half index. And you would have thrown away all of this. Okay. Zero to half index. Okay. So as we keep doing this, it means the array would keep getting smaller. So we can put this in a while loop and say while array.length is not 0, right?
Okay.
Because each time we don't find the value, we keep reducing the array, making it smaller, smaller, smaller. So at some point, we would even remove the final item in the array. So if at that point, it's an empty array, if at that point we've still not found what we're looking for, it means we didn't find the value. You can return maybe null or false or something. But thanks to this, once we find the value, we immediately return that index. Okay. So while what's the word? array.length, while array.length, because 0 is false, any other value is true. So while array.length, all of these should happen. And at the end of the while loop, return null. So this is why it's called divide and conquer. You check this, blah blah blah, you take your queues, this is smaller, you throw away part of the array. So it's like you've divided the array and you're focusing on smaller portions to conquer, that kind of thing. So it's also a divide and conquer algorithm. So let's test it out with binary search, right? And there was a nice array here.
You can just put noise.
5. Why is it returning 3 immediately? Okay. So the index of 5 is 0, 1, 2, 3, 4. So if this works, we should get 4 here. But the way this thing is just looking, let me see. Anytime I do a while loop, I'm always scared, because the thing not go tell you say it will go to infinity. So just keep going. Yes, the previous lesson was recorded, but it has not yet been uploaded. Hopefully this night it will. Hopefully. Because I have to convert it first. It takes a while to convert it. And if it passes the time that I have to off the gen, then I'm offing the system as well. Maybe tomorrow we'll bring anytime rain falls in this place, these people will always behave funny. I don't know what their problem is. They'll off light for 3 days. Don't worry, the links will be posted in the group when it's done. The way this thing is looking, the way this thing is still going is scaring me.
Maybe there is
while array.length. If it becomes 0, then this becomes a false.
It falls.
So it will stop.
And it shouldn't run again.
Exactly, it shouldn't run again. Let me see. If there is only one thing in this array, and I do this, okay. Let's comment this out first. Problem or something. You stop now. I'm using something else that's causing this one. Wow, the bro is still continuing. That's seriously. How did I stop this thing again? Control K E. Okay, now. I stopped. Okay. None. Oh, okay, this one. So this is 0. And we see let me see. What would half index of this? 1 divided by 2 is 0.5. Mat.floor is 0. So if you say slice 0 to 0, yes, you get an empty array. So, that should be. And the other way, array.slice half index plus 1. Oh, is that the problem? Array.slice 0 is still 0. Yeah. Array.slice 0 plus 1. Yeah. 0. So that means each way, whichever way you go, you get empty array. Half index is 0. If you say 0 to 0, you get 0. And if you say array.slice half index plus 1, you'll also get an empty array. So that should not be our problem. So what else is making this one go like this? That's a 0. Or is it because of this? Maybe let array be equal to so in here we just work with array. Because I don't know, I feel normally, these values, these parameters or arguments that are passed in, they can be reassigned. But in case that's what's causing this wahala, then no wahala. We'll reassign this value to a special variable in our function that we can manipulate as we want. So we try again.
You've not changed one line 174.
This one, okay. Alright. So console.log, what's it called? Binary search, right? Control V, yes. 5. Again, it's going off on a tangent.
You just showed 3.
Yeah, I don't even get where that 3 is coming from. Like, how? I said if array at half index is equal to n, return half index, and it was very happy to show me n was nothing at that point. N was undefined.
I can't hear you again.
Yeah, I've been humming to myself. Binary search takes array and n. Something is not adding up, and I'm not figuring out what's not adding up. Yeah, we start out with array, create half index, and while array.length is not equal to 0, yeah, if the item at half index is equal to n, these are all numbers now. If it's equal to n, return half index. Else if it is less than n, then do this. If it is greater than n, do this. I don't know. Let's end here because we're taking too much time. And if I find out what's wrong with this, I'll let you guys know in the group chat. Since actually this was the last thing we're to do in this lesson, so we're stopping here. Binary search. Next time we'll look at sorting algorithms. There are actually 6 different sorting algorithms that I'm familiar with. 3 of them. The first 3 are like, will I say, I don't want to call them basic. Let's call them, should we say, preliminary sorting algorithms. They are like, the way humans think, the way you would expect something to be sorted. Those are those 3, but coincidentally they are like the slowest sorting algorithms. They are O of n squared at worst. Although there's one of them, I think it's insertion sort, so that does, there are different kinds of data. Some data are maybe like reversed, completely reversed. Some maybe almost sorted. Some will be like completely diverse. Those are different situations that actually impact the speed of the sorting with different algorithms. So I think it was insertion sorts with almost sorted, with I think nearly sorted data. It's the fastest. It's even faster than the supposedly better algorithms we'll talk about later on. So the fact remains that understand the algorithms, understand their strengths and their weaknesses, and at different points in time pick whichever one is best for the situation. Yeah, that's just it. There is almost nothing in the world that doesn't have a weak point, that doesn't have where it's not good at. So yeah, that's that. So see you all next Saturday.
Now we look deep.
What?
Like I think we should look deep now to know which particular this thing to use.
Yeah.
Solving a particular. Yeah.
Yes. Always, judge the situation at hand with what you have on ground. Yeah. Don't just make assumptions. Understand the situation. Understand the tools you are trying to work with, or the tools you have at your disposal, and decide: should I use an array or an object for this? Should I use this method or that method for this? Those kinds of things. For example, you are trying to, put some data or store some data, and you want to easily retrieve that data, at the drop of a hat, and you actually have, titles for that data, like properties. So you want to store somebody's name, their age, their this, their that. You go with objects, because with objects you can store values with keys, properties, and you can get them at the drop of a hat. You can easily find out, who this person is, or rather get the data for this person at any point in time. With array, you would have to search through the array. Those kinds of things would, impact your choice of how to proceed. This thing is still playing games with me. God. No worry. I can't stop thinking about this thing now. Haba. Something that I'm looking at and I'm not seeing the problem, yet there's clearly a problem. There's no way I'll stop thinking about it. Anyway, so let's just end here, shall we? We shall meet